Welcome back. All right, now we're going to tackle a new graph, and I want you to notice that this graph has lots of curves, it has lots of solubility curves. So it doesn't just have the solubility curve for ammonia gas like we did in the previous part, it has the solubility curve for a whole bunch of different compounds. And I want you to notice something. I want you to notice that only some of these curves move downward, right? So we had NH3 here, trying to show my laser pointer. We have NH3 here, and we have Ce2SO4 here. But a lot of these solubility curves end up increasing, and that ties back to the types of substances that they are. So right here, we talked about how if you increase the temperature of a solid, it tends to increase the amount that can dissolve. And so we notice that here when we look at these curves, most of these curves tend to face up, meaning that you can dissolve more the hotter it gets. On the other hand, when we talked about gases, as you decrease the temperature, you can dissolve more. So when they're colder, you can dissolve more. And so that falls in line with what we know about here. We have ammonia gas. So less dissolves at hotter temperatures. We'll put that note there. Less dissolves at hotter temps. And so, in general, we see that pattern just when we're talking about gases versus solids. Okay, so let's get to some of the nitty gritty on these questions. Question number one says, which salt is most soluble at 20 degrees Celsius? So, what important information can I get from that question? Well, I can find that it says 20 degrees Celsius, and I can find that temperature on the x axis. So, temperatures on the x axis. Now, what does that phrase most soluble mean? Soluble means can dissolve. So, which salt is most soluble or can dissolve the most? At 20 degrees Celsius. So, we would take that line there and we would hike it up all the way to the top. And then we would try to see which salt would have the intersection at the highest point. And so that is clearly happening up here with Ki. And so then potassium iodide is my answer there. All right, let's look at the next question. The next question says, how many grams of potassium chloride are needed to create a saturated solution in 100 grams of water at 80 degrees Celsius? So let's look at that. It's giving me some information. It's giving me that we're starting at 80 degrees Celsius. So I can go on the x-axis, find 80 degrees Celsius. And it's saying that I'm looking for potassium chloride. So I need to figure out what that is. I think potassium is K and chloride is Cl. So they're talking about this line right here, KCl. And since it's asking for a saturated solution of KCl, that means you're going to look for a point along the line. Okay. Other important information to know is that you're trying to dissolve this in 100 grams of water. And I want you to look at something on the graph because it says that these graph values are per 100 grams of water. Now, that's not necessarily true in some of the questions that come up later. And so we got to be careful with that. So then it says, how many grams of this can I dissolve? So if it's asking for how many grams, that's something along the y-axis. So let's go ahead and make our point. We're going to go 80 degrees. We're going to go up to the line. We want to be on the line for KCl. And then we're going to move over to the y-axis. And that would be 50 grams. Okay, let's try the next question. At what temperature will 60 grams of NH4Cl create a saturated solution in 100 grams of water? So, what we're going to look at is some important information here. So, they tell us that we're working with 60 grams of NH4Cl. So, that's 60 grams, that's on the x-axis. And we're looking at NH4Cl. So, we're looking at this curve right here. Okay, and we're working for a saturated solution. So that's on the line. And we're working with 100 grams of water, which coincides with what it says on the graph here. And we want to know what temperature. So that means that we're looking for an x-axis answer. So we have 60 grams. We're going to go over to where that NH4Cl line is. We want to get a point along the line, and then we want to see what temperature that is, and that would be at 70 degrees Celsius. All right, let's continue. Okay, so at 40 degrees Celsius, how many grams of potassium nitrate are needed to create a saturated solution in 300 grams of water? Notice that that 300 is bolded and it says hint, read the y-axis title. So something different is going on here. We're working at 40 degrees Celsius, so we can find that number on the x-axis. And it says for us to find how many grams. So that would be on the y-axis. And we're looking for potassium nitrate. So that's KNO3. And so that would be along this line here. KNO3. KNO3. Okay, so that's KNO3. And we're making a saturated solution. So that's going to be on the line. But look, this is different. We're working with 300 grams of water. So I want you to pause for just a second, and I want you to think to yourself, maybe even pause this video, what do you think happens to the amount of solute that can dissolve if I increase the amount of water? What do you think? Do you think it would dissolve more? Do you think it would dissolve less? Or do you think that the same amount could dissolve if I tripled the amount of water? All right, so what happens if I triple the amount of water? Well, I'm going to triple the amount that can dissolve. So basically the idea is this. I'm going to take however much I can find on the graph, and then I'm going to multiply it times 3, because this is per 100 grams of water, and this is 300 grams of water. So basically 100 times 3 would give you that 300 grams of water. So that's why I have to multiply by 3. Okay, so on 40 degrees Celsius, I go up to that line, and then I go over to the y-axis, and that gives me 60. But remember, 60 grams is not the answer, because that's only how much can dissolve in 100 grams of water. So I do 60 times 3, because I have 3 times the amount of water, and that would be 180. All right, so now let's look at the last question, number 5. How many grams of cesium sulfate can be dissolved in 50 grams of water? Go ahead and pause the video, and then try this question on your own, and then see what the answer is. All right, so let's try this question. We're looking for cesium sulfate, and that's this line down here, cesium sulfate. And it's asking for how many grams. So that's going to be a number that's on the y-axis. And it says that we're working at 20 degrees Celsius, so that would be right here. And that we're working with 50 grams of water. So that's not what it says on this graph. This graph says 100 grams of water. So how do you get from 100 to 50? Well, I could take 100 grams of water and I could divide that by 2. So whatever answer I'm going to get on the graph, I'm going to take that answer and I'm going to divide it by 2 to get the real answer. So at 20 degrees Celsius, I'm going to go up to the line. I see that that's 10 grams, but that's not my answer. I'm going to take 10 grams divided by 2, and the correct answer would be 5 grams. So now that you've seen these examples, I want you to transfer your answers over here to the solubility curves graph. So notice I'm going to go ahead and put Ki as the most soluble salt. And then here I'm going to put 50 degrees Celsius as my second, or 50 grams. I apologize. Notice how I only put 50, not grams, because it's only going to let you put in numerical answers. And then I'm going to go ahead and put that this next answer is 70 degrees Celsius, right? And notice again, I didn't put degrees Celsius, I just put the numerical answer. And then for this next one, I had 180 grams. And then for this last answer, for this next answer, have 5 grams. So you're going to continue to do the rest of these problems to the best of your ability. If you have a question, please leave a comment in Google Classroom, and I will certainly get back to it by the end of day tomorrow.